Mrs. T's Chem Talk for AP Chem. I'm just going to do a little bit of K practice or rice chart practice. And for those of you who don't know me, my name is Mrs. Tominello. I'm a chemistry teacher at Calhoun High School in Merrick, New York. So for example, we might see a question like this, where they're giving us a 1 liter flask filled with 2 moles of a certain gas and 2 moles, let's just say, of SO2 gas and 2 moles of NO2 gas that are heated. They're in a 1 liter flask, so that means that the molarity is the same as the number of moles when we divide it out. They're telling us the amount of gaseous NO that's present after equilibrium, and they're giving us our overall reaction that we're going to compare it to. So the first thing that we're going to want to do in order to solve this, we need to make sure that we have our K expression. Remember that a K expression has to do with equilibrium values, and the K expression will be equal to the product over the reactants to the power of the coefficients. So we want to make sure that we have that set up so we know what we're setting everything equal to. The next thing we're going to want to do is set up a little rice chart here. You might call it an ice chart, you might call it a rice chart, but for rice it would be reaction and then initial change equilibrium. And while I'm reading it, I notice that it's 2 moles of gaseous SO2 and 2 moles of gaseous NO2. So that means that those values are the initial values, and they're telling us that that's what we're putting in the container. So we are then going to say that the SO3 and the NO, we're going to say that they're starting out at 0. Remember that our reactants and products are sort of on opposite sides here. Whichever one increases, the other one will decrease, so we want to keep those separated. When we plug again that we do moles divided by liters to get molarity, for these charts we're always going to do it in concentration. Once we see what our initial values are, we want to set up our Q expression, which really is just plugging into the equilibrium expression and then making sure that we plug in our initial values to see which way we're going to shift. So since we have zeros for our products over 2's for our reactants, Q is equal to 0. And since Q is lower on the number line than K, we will shift to the right in order to reach equilibrium. That means that our products will increase, and according to the law of mass action, that means that our reactants will then decrease. We put in coefficient X, meaning these coefficients, because remember they react in the same ratios as they are in the balanced equation. Same thing here, we put coefficient X. Change will combine in order to give us our equilibrium amounts. So this would be 2 minus x at equilibrium, 2 minus x at equilibrium, 0 plus x, and 0 plus x. Once we have those values, we can plug in any other information that they give us, and I notice that they tell us that at equilibrium, we have 1.3 moles of gaseous NO at equilibrium, and it was a 1 molar flask. So that means that X is equal to 1.30 molar. So everywhere there's an X, we can plug in 1.30, and then we can plug in 2 minus 1.3 for the other values. Plug these resulting numbers back into the K expression, because now these are the equilibrium values. And what we wind up with is K equals 1.30 times 1.30 over 0.7 times 0.7, which comes out to K equals 3.4. Hopefully that was helpful. If you have any questions, certainly let me know.